Okay, now I'm going to go back to the problems we set up, and let's now work on solving these. Okay, so the first one, we have our system. I'm looking at it and I'm noticing that the x is already by itself in that second equation. So that makes it a good candidate for substitution. So I know the x from one equation has to equal the x from the other at the point of intersection. And I know x equals y minus 6. So I'm going to plug y minus 6 in for the y in that first equation. So do you see that? I'm just using substitution and plugging the y minus 6 in for the x in that first equation. So now I have an equation that just has y's in it. These two y's are on the same side of the equal sign. So I'm just combining them. 1y plus 1y would be 2y. Minus 6 equals 64. So then I'm going to go from there and just add 6. So that's going to give me that 2y equals 70. And then when I divide by 2, I wind up with y equaling 35. Okay. Right now, my job is to find both numbers. So I'm going to take the 35 and I'm going to plug it in for the y in one of the equations. This would be the easiest one to do. And then I'm just going to work it out. So I know x has to equal whatever y was minus 6. So x is going to equal 35 minus 6 would be 29. Okay. So then you typically write a sentence to interpret your answer. So I would say something like, the two numbers are 29 and 35. Okay. All right. And I also normally go and I check it with the words of the problem, like, would the sum be 64? Yep. If I added 29 and 35, I'd get 64. And is the smaller one 29, 6 less than the larger one? Yep. If I subtract 6 from 35, I get 29. So I usually do that as my check. But this would be your answer. Now, they might ask you, since they talked and referred to smaller and larger, they might have a spot for you to put the smaller number and a spot for you to put the larger. And so make sure you put the right one in the right spot. Okay. All right, so with question number 2, okay. All right, so with question number 2, we've got it set up. Again, I see an x by itself right here. So I'm thinking substitution is a good candidate. I'll take and I'll substitute 2y in for the x in the first equation. So I'll get 2y, and then the rest of the equation I'm going to write down plus y equals 180. 2y and 1y would be 3y. And so that means that y would be 60. Okay. And then I've got to find the x as well. And so I'm going to come over to an equation that has an x in it, maybe like that bottom equation. And it says that x would equal 2 times whatever y is. And I just found out that y was 60. So I can put 60 in, and then I wind up getting that my x would wind up being 120. Okay. So the vendor sold 120, and I go back up and see that x was sodas, 120 sodas, and 60 is the y, and y was hot dogs, and 60 hot dogs. They'll probably just have a spot for you to put in how many sodas and then put in how many hot dogs. Okay, so both of those, it worked well to use the substitution method on them. All right, let's take a look at this one. So this was the movie problem. got our two equations sitting here. But I'm looking at how the x and the y are on the same side. So I'm thinking I would just use the addition method on this one. So I could get rid of either the x or the y. If I try to get rid of the x, I could make the numbers out in front of x both be 2. So I might do something like this. I might multiply the top equation by 2. But if I did, that would be a 2x in that first spot, and I already have a 2x. So I need one positive and one negative. So what I could do is just go ahead and multiply by a negative 2. So my first equation would become negative 2x. Let me erase this over here. Negative 2x, negative 2 times 2 would be minus 4y, and negative 2 times 1250 would be negative 25. Okay. And then I'm just bringing the bottom equation along. It's already got a 2. They are opposites like I want them to be. Okay. And that's what I was trying to make happen. I wanted those two terms to be opposite. So when I add, that's going to be 0 and be gone. Then negative 4y plus 5y would be 1y. And then here I have to take a positive 2850 and subtract 25 from it. So I'm just going to get a 350 on that. Okay. Now I need my x. So I could go back and eliminate the y variable if I wanted to, or I could take one of the two equations. So I might just take that first equation, and where y is, I'm going to put the 350. And then work that out, and that'll tell me what x should be. So 2 times 350 would be 7. So x plus 7, $7 or 7, would equal 1250. And then I'll take away 7 from both sides. And I wind up with x equaling, that would be 550. Okay. All right. And then you need to interpret, what's what. So you have to go back up and look at what your x was. Your x was the cost of one large popcorn. So you'd say something like one large popcorn costs $5.50, and one small drink, don't capitalize, and one small drink costs $3.50. Okay. All right, and you can plug in the x and the y in each of these and make sure that you get what you're supposed to get as a means of checking them. All right, let me look at number 4. Pretty much like the other one, their x and the y are on the same side, so elimination would work well. If you wanted to eliminate the x, you could take the top equation by 2, the bottom equation by 5, but then you'd have 10x on both of them. So we'll put a negative on one of them. So the top equation becomes 10x plus 12y equals 14. And the bottom equation becomes negative 10x minus 10y equals negative 15. Okay. All right, so when I add those two equations together, I get a weird result. So I may have to go back and check that I copied this problem correctly. And because it looks like it will not work out to be possible. So I wound up with 10x canceling out, 12 minus 10 being 2y, and then 14 minus 15 being negative 1. And so y is supposed to equal a negative 1/2, and that's supposed to be the length of workout B. So there might be a problem with problem number 4, and I maybe didn't copy correctly the numbers there. but I copied it out of Alex, but you shouldn't wind up with a negative number on that. But the concept should be to do something like that. Okay. And then I could go back and eliminate the y if I wanted to, or I could plug that in for y and work out what the x would be. Okay. So they should both be positive. It wouldn't make sense to be negative. So I'm just going to check real quick on things. So 5 clients did A, and it would be X hours. 6 did B, it would be Y hours, and he worked for a total of 7. And then 2, plan A, 2, plan B, and that's supposed to be just a total of 3. And then 2 all the way through, and then -5 all the way through. I don't see anything wrong with our work, but something logically is wrong with the problem. So just put a hold on number 4, the concept we have about how to set it up, but shouldn't be negative. So I don't see anything wrong with our work. So there might be something wrong with the problem. Okay. But technically what we ought to do is take that -1/2 and be able to take one of these two equations and plug in whatever the time turned out to be, and then go in and work that out and get the time for the other one. Okay, so, but I'm getting a -1/2 hours for B, and 2 hours for A. Okay, and so that doesn't really make sense. So try to let that detail go. It's probably just a matter of me copying the wrong thing out of the problem, and I'll try to go back and check on that and do that, talk more about that in class. Okay. All right, let's go on and look at problem number 5. Oh, but again, there's nothing really wrong about the setup or our approach to solving it. What's wrong is the problem, the situation, the numbers that are in the problem itself wouldn't work, wouldn't be consistent. Okay. All right, so let's go on and let's look at this system. I'm probably going to need more space, so I think I'm going to see if I can't move that question down a little bit. See if it'll let me. Yeah. Okay. Now this problem has these decimals, so it makes it a little harder than when you have whole numbers. Okay, so you do have the option of clearing out the decimals. Let me warn you though, if you do that, you're going to then have pretty large numbers to deal with. So if you wanted to, you could eliminate X by just coming up here and multiplying by 0.035, just make it, let me do it in a different color, by 0.035 and just making it negative. Then you'd wind up having the X's match and it would be eliminated. So you might want to just leave the decimal, and you see if I multiply through by -0.035, I'd have -0.035x minus 0.035y equals, and I had to go get a calculator, 0.035 equals a -210. Then I'm just bringing the other equation as is over. Okay. Now I got it set up so the x's are going to cancel. Then I can take the 0.035 that's negative and add the 0.025 that's positive, and I get a negative, and be real careful when you write it. It's -0.01y. And then when I do the right-hand side, I'm going to get a -15 when I take -210 plus 195. All right, so now I'm ready to divide. I'm going to divide by the -0.01 on both sides. And so I wind up with y equaling negative 15 divided by negative 0.01. So I know it's positive, and it turns out to be 1,500. All right, so I wanted to show you just how to let the decimal, keep the decimals as is, and just multiply through by that negative 0.035, and it works fine, and the numbers stay smaller as you're working. Okay? But I did want to comment on an alternative you could do. Instead of multiplying by that 0.035 and making it negative, what you could do instead is you could clear the decimals. You could multiply here by 1,000, multiply here by 1,000, and multiply here by 1,000. But then your equation becomes 35x plus 25y equals 195 with 3 zeros. And so you introduce a rather large number, but you could do that. And then what you could do is multiply up here by 35 that's negative, instead of having to deal with the decimal. So it's kind of up to you, which route you would follow on that. Some people mess up more when they get these really large numbers, okay, or they forget to multiply the right side by 1,000, but others don't like dealing with the decimals throughout. Okay, so let me stick to the first way we did it. I just wanted to comment on that in case that made more sense to you. All right, let me erase. Get it to let me erase here. There we go. All right, so you see the option. Okay, but now we got to finish the problem. So what we know is what the y is. The y is 1,500. So what we have to do is take one of the two equations. Clearly, the top one is the easier of the two. And right there, where y is, I'm going to put 1,500, and I'm going to work that out. So I'm going to subtract 1,500 from 6,000. And when I do, I'm going to get how much was invested. $4,500 is what I get. So x would equal 4,500. Okay. And that would be how much is invested in the 3.5% account. So you really should then interpret the question. Okay, so let me see if I can. I want to get all these out of there. Okay, I just was trying to get some more space. All right, so what you should do after you've answered the question is you should then write a sentence interpreting what you found. So who was the person? Joanne. So Joanne invested $4,500 in the 3.5% account and 1,500 in the account paying 2.5% interest. Okay, so something like that. And they may just have a spot for you to put in the 4,500 and the 1,500 in the appropriate spots. Okay. All right, so let's check on number 6. All right, so number 6 got kind of messed up looking. So let me go ahead and just move it to a new page, and I'll clean that up a little bit, and then we'll work it out. So we'll insert page break and take a look at that guy. Okay. That's too far. All right, there we go. Okay, so here we have the one which was also perimeter equals, principal equals rate times time, or principal times rate times time equals interest problem. Kind of hiding, there we go. It was the same type using the same formula. It was just a loan rather than amount invested. So we have our two equations. It's the same deal. What I would do here is use elimination and just multiply this first equation by 0.05 and make it negative, so it'll be the opposite of what I have down here. So that would be negative 0.05x minus 0.05y equals, and then I take 35,000 times 0.05, and that would be, and it's negative, so that would be negative 1,700. Then I'm just going to bring the other equation over as is, and I had adjusted the first equation, so when I add these two, the x is going to cancel out. So I'm going to get 0.02y, because that's a negative 0.05 and a positive 0.07 will be 0.02. And then 1950 minus 1700 should be 250. And so I just need to take 250 divided by 0.02, and I get 12,500. Okay. All right, and that 12,500, that's the amount borrowed. So Arlene borrowed $12,500 at, and that was what? Y at the 7% rate. And then we need to find the x. So I'm going to go take that equation that says the two together, the amount borrowed all total was 34,000. So if she borrowed 12,500 there, I can find x by just subtracting the 12,500, can't I? So that's what I'm going to do. And take away 12,500 from the 34,000, and that'll tell me what my x is. So I wind up with 21,500 for x, and then you have to interpret that. So she borrowed 12,500 at the 7% rate, and the rest, 21,500, at the 5% rate. Okay. All right, so the solving part is a little more straightforward. I just wanted to do it because it involves decimals and things like that. Okay. All right, and then let's look at these last two problems that deal with the distance equaling rate times time. So once you get your system, so now I'm just focused right here on where we have our two equations. You look at it. This one looks like a good substitution problem because of the x being by itself. So I'm just going to substitute y plus 10 for the x in the second equation. So 2, and right there I'm going to put that y plus 10 that I found. Goes right there. Okay. So 2y plus 20 plus 2y equals 52. These are on the same side of the equal sign, so that's 4y plus 20 equals 52. Okay. Let me see if I can give us a little more room here. I'm just going to insert a page break, go back, up, and finish that. Okay, so see how now, once we did the substituting step, we have an equation with just one variable in it. So we're just using our chapter 2 skills. 4y plus 20 equals 52. So I'm going to subtract 20. That gives me 4y equals 32. And when I divide by 4, I wind up with y equaling 8. All right, now I need to find x. So I'm going to go to the equation x equals y plus 10. And I know y is 8. So I know x is going to be 18. All right, so what is that? So the faster cyclist, one cyclist, the faster cyclist is going, faster cyclist is going 18 miles per hour, while the slower one is going 8 miles per hour. So you go back and you just look at what was your x, what was your y. Okay, So your y was the slower cyclist's rate and the x was the faster one. So that tells you, what it is. It's the speed. It's miles per hour. Okay. Okay. All right. And then one more was another rate times time equal distance problem. And we have our equation set up. This one has those parentheses that make me think about distributing. That would probably be the most natural thing everybody would do. There are alternatives that would be correct, but that's probably the most obvious thing to do. You could have divided by 2 on both sides, for instance, and gotten x plus y equals 4. Here you could divide by 4 and get x minus y equals 2. But probably the most natural thing is to just distribute and then look at it. And I'm thinking I might eliminate y this time because I can make the number in front of y's to both be 4. So if I multiplied the top equation by 2, that would give me a 4y right here, and then it would be the opposite of what I have in the second equation. So that's what I'm thinking I'll do, okay? So I'm going to go ahead and move over here. So the top equation becomes 4x plus 4y equals 16. I multiplied all the way through by 2. Bottom equation, I'm just writing what was already there. I've got it set up so the y's canceled out. I could have canceled out the x's. I could have multiplied by -2, for instance, to get rid of the x's. But I just had noticed the signs were already different, so that's why I eliminated the y's. So I get 8x is 24, which means x turns out to be 3. And then I can go to any of the equations. So I'll go to the 2x plus 2y equals 8 and let the x be 3 and see what the y turns out to be. So that's 6 plus 2y equals 8. So I'll subtract 6 and get 2y equals 2. And when I divide by 2, I wind up with y equaling 1. Now, what were the x and the y? That's why it's important that you write down x is the speed in still water. So the speed in still water is 3 miles per hour. So that's like the how fast the kayaker travels that's due to the kayaker himself. Okay. The speed of the current is 1 mile per hour. Okay, so that's how fast the water itself is moving. So notice, just out of curiosity, notice if I had divided by 2, I'd have x plus y equals 4. And if I had divided by 4 here, I would have had x minus y equals 2. So notice that 4 would be the speed of the kayaker plus the current. The current would be helping him. X plus y, remember, was the speed, the rate with the current. And then notice that 3 minus 1 would have been 2 because you're going against the current. So the current is being subtracted. The speed of the current is being subtracted from the kayaker's speed. Okay. All right. So there you have it. That's what you need to know from section 4.4. Oh, and back to question number 4. I'll look up another one of those and we'll do it in class. But I'm pretty sure I copied that correctly right out of Alex, but maybe I made a mistake somewhere. But it's an impossible situation. Shouldn't turn out to be negative, and it definitely does. So something's wrong on 4. Okay.